Good afternoon, students. I, Professor Arvind Muddebihar, welcome you to the subject Kinematics of Machines. In the previous class, we studied about the basic definitions of the link, elements, what is mechanism, what is machine. Okay, and today we are going to start with the constraint motion. And in the previous class, I'll just go through. We have also studied this kinematic pair, types of kinematic pairs based on the nature of contact. We have a lower pair and higher pair based on the relative motions. We have sliding pair, turning pair, cylindrical pair, rolling pair, spherical pair, helical pair, and based on the nature of mechanical constraint, we have closed pair and unclosed pair. Today we are going to start with constrained motion. So what is this constrained motion? In a kinematic pair, if one of the element has got one definite motion relative to other elements, then the motion is called constrained motion. So you take any kinematic pair. In that kinematic pair, if one of the element has constrained or restricted to the definite motion relative to the other elements, then that motion we call it as a constrained motion. This constrained motion is again we can classify as first one. We have completely constrained motion. If the constrained motion is achieved by pairing the elements by themselves, then it is called completely constrained motion. This is nothing but when the two elements, okay, are constrained by themselves, means there is no external devices are used for constraining them, then it is called completely constrained by themselves. For example, if you take this figure where you can see in a cube we have a slab fixed inside the slot, so we do not need any external devices here to hold these two elements together, and the motion of this slab is only in the horizontal direction, that is in only one direction, and it cannot rotate, okay, and it cannot go either in upward direction or in downward direction. It can only slide in the horizontal direction, so it is constrained by itself, okay, due to its geometry, okay. So it is called completely constrained motion. Next we have successfully constrained motion. If constrained motion is not achieved by pairing elements themselves but by some other means, then it is called successfully constrained motion. And we can take example of footstep bearing, where shaft is constrained from moving upwards by its own self weight, okay. You take this figure, okay, here we have a footstep bearing. When the shaft tends to rotate in this bearing, usually the shaft has to come out of that slot, but due to the self weight of the shaft, it remain in the slot and rotate there itself, okay. So such type of uh, constraint for the movement of the shaft, okay, we can take as an example of successfully constrained motion. So here you can see, I will repeat once again, okay, this is the footstep bearing. The shaft tends to rotate and naturally it has to come out of the slot, but due to this load that tends to shaft push downward and it remain in the slot itself, okay. So this is called as a sorry. This is called as a successfully constrained motion. Next we have incompletely constrained motion. When relative motion between pairing elements takes place in more than one direction, then it is called incompletely constrained motion. Example is shaft in a circular hole. So you can see in this figure, okay, this is a circular hole and where you can put the shaft in the circular hole. Now this shaft can either can rotate in the hole or it can also slide in horizontal direction. So such motion we can call it as incompletely constrained motion because the shaft do not have definite motion in any one direction. Okay, either it can rotate or it can slide. Such a constrained motion is called as a incompletely constrained motion. So these are three types of constrained motion. Next we have kinematic chain. So here in a kinematic chain, it is a group of links either joined together or arranged in such a manner that it permits them to move relative to one another. If the links are connected in such a way that no motion is possible, it results in locked chain or structure. So here in this figure, what you can see is a locked chain or structure. See, these three links are connected in such a way that there is no relative motion is possible between them. Okay, so it is fixed to their position. So such a links are called as a locked chain or structure. If there is a relative motion is possible between them, then it is called as a kinematic chain. So next we have mechanism. A mechanism is a constrained kinematic chain. This means the motion of any one link in the kinematic chain will give a definite and predictable motion relative to each other. Usually one of the links of the kinematic chain is fixed in a mechanism. So here we have two examples over here. Okay, one is a slider crank mechanism and a 4-bar mechanism. Okay, so in a mechanism you have to understand that one of the link will be fixed. Okay, so in this example, this is the one where we consider link number 1 which is fixed. Okay, and here in this example, this is the link number 1 which is fixed. Okay, this and this is considered as a only one link. Okay, this fixed base link is considered as link number 1. Okay, and when we fix this link number 1, link 2, 3 and 4 will be having relative motion between them, and this relative motion is definite and it is predictable. So it is called as a mechanism. That is nothing but link 2 can have a complete rotary motion. Okay, link 3 can oscillate and link 4 is going to slide. Okay, so it has a predictable motion, that is definite motion, so it is called as a mechanism. And similarly in this 4-bar mechanism also, link 1 is fixed, link 2 can have a rotary motion or oscillation, rotary motion, link 4 can also have a completely rotary motion, and link 3 can have a oscillation. So again here, by fixing the link 1, here we are providing a definite predictable motion to the remaining links, that is nothing but they are having relative motion between them. Okay, so such a system we call it as a mechanism. So next we have a machine. So already we have discussed yesterday what is a machine. A machine is a mechanism or collection of mechanism which transmit force from the source of power to the resistance to be overcome. Through all these mechanisms, machines are mechanisms, but mechanisms are not machines. Okay, so this is what we can say. So machines are made up of mechanisms. Okay, using different mechanisms or combination of mechanisms, we create machines. That is, power will be converted into useful work. But a single mechanism, we cannot say it as a machine. Okay, so here the saying is that machines are mechanisms, but all mechanisms are not machines. Okay, that you have to understand. Okay, and there are many examples of machines, lathe machines, paper machines, etc. Okay, all are machines only. Okay, next we'll have a look into difference between machine and mechanisms, and in few of the examinations these differences are also have asked. Okay, so let us see what is the main difference between the machine and mechanism. The first one is machine modifies mechanical work. That is nothing but machines are used for making power or using source of power into converting into useful work, whereas mechanism transmits and modifies the motion. Second one, a machine is a practical development of any mechanisms, whereas a mechanism is a part of a machine. Okay, so using mechanisms the machines are developed, and the mechanisms are just a part of the machines. Third one, a machine may have number of mechanisms for transmitting mechanical work or power, example lathe, shaper machine, etc. And whereas mechanism is the skeleton outline of the machine to produce motion between various links, example clock that works using the mechanism, and typewriter are again mechanisms. Okay, where it provides the uh, relative motion between the various links, but in the machine it uses mechanism for transmitting mechanical work into power. Okay, so that is the difference between the machine and the mechanism. Next we have difference between the machine and the structure. So to start with difference between machine and the structure, the first one, the machine is a one where relative motion exists between the parts, where in case of structure there is no relative motion exists between the members. And in case of machine, links are meant to transmit motion and power, whereas in structure the members of a structure transmits only forces. There is no transmission of motion in the structure. And in the machine it is meant for transmitting useful energy to do certain type of work. Okay, and example of machine, again you can give lathe and shape machines as the example of machines, where in case of structures no useful energy is transmitted by it. Okay, so it only just transmits the force. Example, you can take roof trusses. Okay, and again machine frames, where it provides the structure for the machine. Okay, so this is the difference between the machine and structure. I repeat, these differences are asked in the examination. Okay, you better understand and remember these differences. Next topic we have degrees of freedom. So it is the number of inputs or number of independent coordinates required to describe the position or configuration of all the links of the mechanism with respect to the fixed link at any given instant is called as a degree of freedom. Okay. By knowing the degree of freedom, one can understand that what is uh, the one can predict the motion of the mechanism. Okay, so if you have four links in a mechanism, so by knowing this degree of freedom, okay, you can predict its motion, and you can constrain the motion of any of the element to have a definite or required motion of the mechanism. Okay, for example, when two elements are pulled together, and if one element is able to slide in only in horizontal direction, then we can say it as a single degree of freedom. Okay, and we have already come across a shaft in a circular hole example, where shaft can have a rotary motion. Also the shaft can have a sliding motion, that is, it can slide in the horizontal direction and it can rotate also. Okay, then we call it as a 2 degrees of freedom. Okay, so by knowing the degrees of freedom, okay, one can constrain the motion to get the required mechanism or the required motion in the element. Okay, Grubler's equation. Okay, uh, this is used for finding the number of degrees of freedom from a given mechanism. And this is the formula what we have as a Grubler's equation for finding the degrees of freedom. F is equal to, F indicates degree of freedom, F is equal to 3 into n minus 1, and this close the bracket, minus 2 into L minus H. Okay, where L is the number of lower pairs and small h is the number of higher pairs. This equation is used for finding the degree of freedom for the given mechanism. Okay, and here we have symbols which are used for single link. Okay, here you can see one circle with a line. Okay, this indicates the singular link. If you have two circles at the both ends of the link, then it is called binary link. And then in the triangular shape or this shape, if you have a link, then it is called ternary. And this you can see there are four circles, 1, 2, 3 and 4, and this is joined with the four links, then it is called as a quaternary link. Okay, this knowledge you should have for finding degrees of freedom using this Grubler's equation. Okay, and let us see a few problems on the Grubler's equation for finding the degrees of freedom. Okay, first let us take this simple example over here. This is a mechanism. Okay, and we have to find what is the degree of freedom for this mechanism. The equation is F is equal to 3 into n minus 1 minus 2l minus h. Okay, so n is the number of links. So first we need to find how many links are there. So here you can see this is link number 1, this is 2, link number 2, this is link number 3, this is link number 4, this is link number 5, and this triangle which is shaded is completely considered as one link, so it is 6, link number 6. So small n is equal to 6. Totally there are 6 number of links. Next we have to find L. What is L? Number of lower pairs. Okay, we need to find number of lower pairs now. So let us consider number of lower pairs now. So this is one pair which connects between link number 1 and 6. So this is one lower pair 1. This connects between 1 and 2. So this is lower pair number 2. Next here you can see this connects between link 2, 3 and 4. Therefore here we need to count 2 number of lower pairs. Okay, so totally now we have 4 lower pairs. This is 1, 2, 3, 4. Okay, and here it connects between link number 4 and 5. So this is lower pair number 5. And here it connects between 5 and 6. So this lower pair number 6. And here it connects between 3 and 6. So lower pair number 7. So totally we have 7 number of lower pairs. 1 which connects between 1 6, which connects between 1 2 is 2, which connects between 2 3 4. We need to count as 4 2. So totally 4. And this is connects between 4 and 5 is 5, which connects between 5 and 6 is 6, which connects between 3 6 is 7. So totally there are 7 number of lower pairs. So L is equal to 7, and there is no higher pair. What is higher pair? Higher pair means there should be point contact or line contact. So such links are called as a higher pair. So there is no point or link contact between them. So H is equal to 0. So substituting value of N is equal to 6, L is equal to 7, okay, and H is equal to 0. We found that degree of freedom for this mechanism F is equal to 1. So this is how you can find out the degrees of freedom for the given mechanism. So this is the example number 1. So let us see the one more example. So let us take the next example. So this is the mechanism what we have. So again we need to find the degree of freedom for this mechanism. So here you can see these all are the fixed links what we have. All these fixed links are considered as only one link. Okay, so you can imagine if you have a single link like this, okay, so that can be used as a one link. Okay, so imagine in such a way and consider all these fixed link as a link number 1. So this is link number 1, this is 2, you can consider, this is 3, 4, 5, 6, this whole link is 7, 8, 9, 10 and 11. Okay, so totally there are 11 number of links. So small n you can consider as a 11. Okay, I repeat once again, these all fixed links you have to consider as 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So n is equal to 11. So next we need to find the number of lower pairs. How many lower pairs are there? So let us count the number of lower pairs. So this connects between 1 and 2. So it is 1 lower pair 1. This connects between 1 and 3. So it is 2. It connects between 3, 4, 5. So we have to count here 2. So 1, 2, 3, 4. Here we have to count it as 2 because it connects between 1 and this link and this link. Okay, so again here we have to count it as 2. So 2 plus 2, 4, 5, 6, this is 7, this is 8, this is 9, and here we have to count as 2 because it connects between this link and this link. So 9 plus 2 is 11, and again here we have to count as 2 because it connects between here this link and this link. So 11 plus 2 is 13, this is 1 14, and this is 1 15. Okay, so there are 15 number of lower pairs, and again there is no higher pairs is present. So h is equal to 0, l is equal to 15. By substituting this, we can find that degrees of freedom is 0. Then it is, we can say it as a there is no degrees of freedom, there is no motion in any direction. Okay, let us consider one more example now. Okay, let us take this mechanism. Okay, here you can see the link 1 is shaded with lines. Okay, it's a triangle. What you can see, that is considered as one complete link. So this is link number 1, which is fixed. This is link number 2, and link number 3 is this shaded area. This triangle, what you can see, is completely considered as link number 3. This is link number 4, this is link number 5, this is link number 6. So totally n is equal to 6. Total there are 6 number of links. Next, let us find the number of lower pairs. So this connects between 1 and 2, so it is 1. This connects between 2 and 3, this is 2. This connects between 3 and 4, this is 3. This connects between 4 and 5 is 4. This connects between 1 and 6, this is 5. This connects between 5 and 6, this is 6. This connects between 5 and 3 is a 7. So 1, 2, 3, 4, 5, 6, 7. Totally there are 7 lower number of pairs, and there is no higher pair is involved. So L is equal to 7. So number of degree of freedom is equal to 1. Okay, that means one input to any one link will result in determining, that is a definite motion of all the links. Okay, so this is one example what we have. Now let us take example of these cams. Okay, here you can see this is one cam profile and this is another cam profile. So in this case, first we need to find the number of links. So this is one fixed link and this is one fixed link. As I said, the fixed links are considered as one link. So you need to consider this as 1. This is link number 2 and this is link number 3. Okay, so n is equal to 3. There are totally 3 number of links. Next we need to find the number of lower links. So here 1 and 2 is connected here, that is one lower pair. 1 and 3 is connected over here, that is one more lower pair. Okay, so number of lower pairs are 2, so L is equal to 2. Okay, and between 2 and 3 there is a point contact between them. Okay, so as we know that for higher pair, if there is a point contact or line contact, we consider as a higher pair. Therefore h is equal to 1. Okay, substituting in this formula, that is f is equal to 3 into n minus 1 minus 2l minus 2h, 2l minus h. Okay, in this formula, these numbers, we calculate number of degree of freedom f is equal to 1 for this particular example. Okay, similarly we can consider the other examples. Okay, I'm going to post the other examples on the WhatsApp group. Okay, and I ask, or I request you to solve those examples, find the degrees of freedom for the posted examples, okay, and you can send your answer in the WhatsApp group also, okay. So this completes the what the problem is on the Grubler's criteria, okay, and we'll see in the next class other theory portion of the syllabus, okay. uh, so I'll post the other examples on the WhatsApp, okay. Please solve the problems. So we'll meet in the next class, and regarding this class, if you have any queries, any doubts, you are welcome and you are free to ask your doubts on the phone call, okay. Thank you.